This is going to be an introduction section. To polar coordinates. Now we are very familiar with rectangular coordinates, which is basically plotting on the coordinate plane, the Cartesian plane. It's called a rectangular, rectangular coordinates, but sometimes it becomes much more convenient to be able to graph in circles. It's very hard to graph circles in rectangular coordinates, and even if you do, you end up with all these weird irrational numbers. And for example, just to show that, let's say I have a unit circle here, and I want to define that point right there. That is halfway in the arc. That on the unit circle is square root of 2 over 2 and square root of 2 over 2. Or if I'm using rectangular coordinates, I'll have to use square root of 2 over 2 over square root of 2 over 2. But if I were to use polar coordinates, I can just easily define this as 45 degrees with a radius of 1. Okay, so the numbers become much more simpler when I use polar coordinates for some of these. And also polar coordinates are good when there are periodic properties, such as trigonometric functions. Trigonometric functions are much more easier to visualize on polar coordinates because on a rectangular coordinate, for example, if you're drawing a sine graph, they kind of go on forever in both directions, so it's hard to visualize the whole thing in one picture, right? Whereas in polar coordinates, it becomes circular, so it's easier to visualize. And even in complex variables, you can find complex solutions better with polar coordinates. Okay, so we are learning polar coordinates now, and the basics of polar coordinates are rho and theta. Okay, so rho is the distance. You can think of that as the radius, distance to the origin. And theta is the angle it makes. Angle it makes with the positive x-axis, or you can think of it as the angle of rotation. So if you were to plot this point right here in polar coordinates, it would be 1, 45 degrees. Okay, and there is actually different system of graphing for polar coordinates, or a graph paper for polar coordinates. Can you pull that up here just a little bit? So this is what a polar coordinate graph paper would look like. And as you can see in the middle here, we have something that's much like the origin. You actually call that the pole. You can think of that as the origin. And you can see that there are bunches of concentric circles. And the center of that circle, for all of these circles, is that origin right there. And much like in rectangular coordinates, the positive x-axis is the 0 degrees, and then it moves this way depending on the degrees. Okay, so if you were to plot 145, it's going to be like around right right there. Okay, and if you were to plot 245, so same angle but one radius bigger, it can be like right there. So notice that as the radius increases, it just goes up by 1 like that. And one interesting thing about polar coordinates is on a rectangular coordinate, for example, if I had a point 1, 2, there's only one point corresponding to that point right there. But if I say 145 degrees on polar coordinates, there are other points who fall on the same point as that. And you might guess if you add 360 to that, you're going to end up on the same point. So 145 is that green dot right there. 405 is just one. It just goes around once more, so it just lands right on top there. So these 2 points have the same point on the polar coordinate. So those are called coterminal angles, or coterminal points in this case. And you can get coterminal points by adding or subtracting 360 degrees. So this has been a very brief introduction to polar coordinates. You can become a little bit more familiar with using these this polar graph system. For the graph system, just remember that every time you go once, that's the radius. This is the radius. And then for each angle, you're going this way. Okay, so if you have a point, count the number of radii you need to go, and then count the angle of rotation to plot the point.